is Parth from FTC Team 7477, and today we're going to be talking about the basics of servos in FTC programming. So last video we talked about motors, and today we're going to be talking about servos. Servos are generally a little bit easier than motors to program. So our first step is to start with the initialization of the servo, which is very similar to the initialization of a motor. So we're going to create a variable using the object servo. Motors have the object DC motor. Servos just have the object servo. And again, we can just hover over it and import the class. We can name the servo anything we want. Let's name it servo1. Again, we're going to use a hardware map to initialize the servo. We can do this by setting servo1 equal to hardware map.get, and instead of DC motor.class, this one's going to be servo.class. And the name here is, again, the name that you use in the configuration on your driver station. So I'm just going to call it servo_1. Remember, this has to be the same exact word for word as your configuration. Okay, so again, very similar to a motor. Now we have our servo initialized. We can actually talk about how it works. So there is the main method associated with a servo is called the setPosition method. And what this does is, of course, it sets the servo to a position. And servos operate on a range of bounds from 0 through 1. Now, servos the bounds can differ based on how you servo program them. Servo programming is a tutorial we'll have for another day, but it's a physical device that you use to program the servos. But they move from a 0 to 1 position. So you can put anywhere from 0 to 1 in this servo. So it'll throw an error if you put anywhere outside the bounds, but 0 through 1 is what you want to input. 0 being the most on one side, right, being 1 being the most on the other side. So for example, let's put 0.5, which should be in the middle of its angle of rotation. This would set the servo position to 0.5. Oftentimes, you want to use a servo.setPosition multiple times in the op mode, but you also use it often in the initialization to have the servo set to initial position. Now, one method that you can also use in the servo is the servo.scaleRange method. And what that does is it scales your range to make a new range. So it's used to shorten your range. It takes a specific point in one bound and a specific point in both bounds and makes them the new 0 and 1 bounds. So let's say I want to make my angle of rotation for the servo a bit smaller. I can scale it to be the 0.2 of the current bound to be the 0 of my new bound, and the 0.8 of my current bound to be the 1 of my new bound. So if that doesn't make sense, we can code it out. So it'll look something like servo1.scaleRange, your maximum and minimum range. So now the new bounds 0 through 1 are actually the original 0.2 to 0.8, and anything that's between that 0 and 1 is proportional to the difference from the 0.2 to 0.8, meaning any bounds lower than 0.2 and anything higher than 0.8 will no longer be able to be moved to by the servo. There's one other method in the servo, and that is called the servo.getPosition method. And what this does is, of course, returns the servo position. But I have a disclaimer about this method, servo.getPosition, is that it doesn't really return the position that the servo is currently at. It returns the last position that the servo was set to. So if you're programming correctly, you shouldn't really need to use this method at all, because all it is returning the target of the servo. There are definitely some situations in which you can use it, but just remember that it is not the current position of the servo. It is a position that the servo is set to be moved to because of the way that the servo receives data from the web hub. Now, lastly, there's another type of servo that we're going to be talking about called continuous rotation servos, which are servos that move just like motors by spinning continuously 360 degrees. And this can be initialized using the object CR servo instead of servo, and we can call this servo2. And the initialization is the same except for the fact that instead of using servo.class, we want to use crservo.class. Configuration name, I'm just going to name it servo2. So CR servos in programming are basically the same as motors in terms of setting power to them. So all I need to do is just servo2 dot set power and choose a 0 through 1 value, and it's essentially the same as a motor. So I can just put 1 here, and that will set the servo to a power of 1. Now, an important thing to remember is that you cannot program a servo into CR servo mode unless you've switched that with a servo programmer. And there's many tutorials online of how to utilize a servo programmer to do that. So that is all for today's video. Thank you for watching, and I hope you learned how to program servos in FTC.